Yeah. Let's see, share preloaded slides.
Did you click on next to your name, the share screen, and then you do share preloaded slides? Is that how you did
Yeah,
that?
except I haven't seen the agenda slides yet. No, here they are. Yeah.
Great. We do have a pretty to the minute agenda, so I say we get started.
Yeah. So we'll just kind of write minutes later based on the recording.
Yeah, I'll just do that. It's worked out well so far, so I'll just
Yeah.
do that
Yeah.
later after.
I'm starting to
Okay.
do taking minutes now, so
Thank you. Perfect.
Okay. Awesome. All right. Yeah. Shall I start here then? I guess I
Yeah,
usually do this bit.
please. Yep, please.
All right. Welcome everyone to PIM here in Vienna, except most of us are not in Vienna. Um, yeah, we got the full agenda. Let's see. Got the note well. Hope everyone has seen that. It's the same as it's been a long time. Um, then we got our agenda. So two first presentations will be about our DR solutions. So we should try to compare those solutions and see what to do, whether we want to stick with one or merge them, or maybe go move forward with both, or but at least we need to figure out what we want to do. Then we got uh, yeah, the point-to-point policy ping, which is a working group draft. We got the PIM Lite, which has been presented before. Then there are several pretty new things. Let's see, the snooping yang. Um, that's something that was taken out of the snooping yang previously to be able to publish without waiting for references. But now we might want to move forward with this. And then there's several other new proposals as well. Looking at the working group status, we got the PIM Yang model. It's still in the RFC editor's queue. It's been there a very long time. It's still waiting for some final references, I assume.
please.
Okay. We got the IUP MLD Snooping Yang model, which finally got published, so that's great. We got the BFD point to multi-point use case published as well, so we're making progress. We got the IGMP MLD extension draft, which has been approved. It just needs the lazy author, which is me, to do a final update before it can be published. Um, yeah, I'll send an email to that to the working group later, I guess, about what changes we're going to make. Not nothing too dramatic. Then we got the DR drafts that are presented this meeting. A GMP MLD proxy Yang. We requested publication of that. Um, Sees more drafts here, like the packing drafts. We also requested publication. Um, a few drafts not presented this meeting. We need to look into the IGMP biz again, but yeah, nothing this meeting. There's also a Lisp draft that got adopted that is not being discussed, and the point to multi-point policy ping will be discussed. That's our status. Any comments on this? There is someone I'm hearing like a buzzing. I don't know if you're trying to say anything or.
Yeah, no idea. Just ignore until it gets worse, and I'll have no idea
Yeah,
what to do then.
Yeah. Okay. So shall we just start with our first presentation?
Let's do. If Sandy's available, let's have her
Yeah,
go.
is she here? No.
How about Makamana then? Let's start with him. He's on both drafts.
Yeah. Yeah, let's start with the second.
So you can pull my slides by the time we do it.
Yeah, so I think you should be able to control your own slides. I don't know if you want to, but let's see.
No, you can present. That's fine.
Yeah, no, I mean, I think, anyway, let's see.
So we can go to the first slide.
Yeah, so yeah, just tell me when to go to next. Yeah.
Sure. So good morning, good afternoon, guys. So the first thing is to talk about the problem statement. So this basically our current PIM RFC. It talks about how to elect a PIM DR in the LAN. And in this case, we are showing that R1 is the DR, and it could be based on IP address or based on its configured priority. Now, what happens that when there is any failure, and let's consider that R1 fails, amount of time it is going to take where R2 or R3 is going to take over as a new DR, it depends on multiple factors. And some of the factors are, first thing is to detect the failure, how fast we are able to detect that there is a failure. And then depending on the hardware capability, how much time we are taking to reprogram the routes. And then how much time we are taking to rebuild the tree. And again, rebuilding the tree will totally depend on how diverse your network is. So there are many deployments where these kind of mechanism doesn't work pretty well, and they don't want any downtime, because in this case, if you see, worst case, if we don't have BFD and we just rely on hellos, we may take up to minutes to even detect that DR is down. So there was a need for some kind of mechanism, some protection mechanism where we could really do fast failover. And that is where this draft comes into the picture, that how can we come up with a backup DR which can keep things ready in case of failure. We can go to the next slide. Now coming to the backup DR election, how exactly we should be doing backup DR election. So what this draft talks about, that to have a very simple mechanism. So I have just pasted from 7761 that today our DR election mechanism is based on our priority and our IP address. So everyone, whether it is R1, R2, and R3, they run exact same algorithm to identify whether I am eligible to be DR or not. So what I'm saying, instead of doing some extra signaling between these routers, why not to run same algorithm, and now you find if you are the second best. So in this case, when R1 runs the algorithm, R1 knows that R1, R2, and R3, all three are in the LAN, and priorities are 100, 90, and 80. So R1 picks itself as a DR. Now, when R2 is running the same algorithm, it knows that it is the second best router. So in case you are second best router, you definitely can qualify for backup DR. Now the role of backup DR is to build the tree all the way till source, and you may backup DR will be getting the traffic as well, but backup DR is not going to forward it to the access, and backup DR is going to forward it to access only when R1 fails. It is it is kind of when you change your role from BDR to DR, that is when you start forwarding the traffic. The benefit of this mechanism is now all the states are already ready. As soon as you detect the failure, maybe there will be BFD running or some other mechanism where you can really detect the failure very fast, and you will be immediately able to start forwarding traffic to the access. So this kind of provides a mechanism where you will have minimum traffic loss. So this is the mechanism of backup DR election. Next. So that was one part of draft. The second part of draft, I think, which we started discussing over email, is sticky DR behavior and why do we need sticky DR. So again, there are deployments where they don't want to have DR election happening in case of any new router comes into the network. It could be accidental config, or it could be maybe customer is really trying to bring up a router which was earlier, which was up and running, which went down, and now it's coming up back. In these cases, you don't want your DR to change, and the reason for that would be again the kind of churn which you are going to see in your network. So just because of one new router coming into the network, or some router kind of went down and came back up, you don't want so much churn to be happening in network. And that is where there are many customers who are looking for a sticky DR functionality, where once one router has been elected as a DR, it should just stick to the whole network should stick to that particular router unless it fails. And that is where a sticky DR requirement comes. And next slide. Now, sticky DR procedures, again, we were thinking about it, that how can we do with very minimum protocol extension. So the one of the step which looks pretty straightforward and easy to do is, so first step is, let's have DR election as it was happening today. So in this case, R1, R2, and R3, they have 3 priorities configured. So priority 100 is the one who is going to take over as a DR. So there is no change in DR election procedure. Next step. And now this is where something new we are trying to define, that once you have taken over as DR, we are looking at R1 now announces its priority as PIM-DR max. When I say PIM-DR max, so basically we can have a reserve number or reserve priority, which is really the max value, which should not be user configurable value. And it is kind of a R1 is getting a semaphore that now R1 gets that max value. R1 starts announcing its own priority as this highest priority. Now, what benefit we are going to get out of it? When R1 starts sending this PIM-DR max priority, no matter who is coming or who is going in the network, it is never going to change the DR behavior. It is not going to cause a DR re-election. But to remember that even though R1 has been configured with priority 100, now it is announcing a special DR priority. Next. Now, when sticky DR fails, or the router which was DR earlier fails, so what is going to happen? So in this case, when R2, R3 detect that there is a failure, they are going to rerun a DR election. And if there was a BDR will automatically take over. And now R2 is the one who is going to start sending this new DR priority. At this point of time, what is going to happen, even if R1 comes back? So R1 priority is configured priority is 100, but R2 is announcing PIM-DR max, which means that R1 will never take over, because R1 is always going to run its DR algorithm against this DR max priority. Next. So implementation wise, yes, this particular sticky DR behavior has been implemented and deployed as well. Next. And with respect to IANA consideration, I was thinking, and maybe we can definitely discuss whether this should be just a user-driven approach, or we can reserve some range of values from the PIM-DR. So PIM-DR is, if I remember correctly, it's 32-bit value. So there was a thought that we can reserve some last towards end some values which you should not be allowed to configure, and we will use one of the number as a max DR value. And the second thing which needs to be discussed is, should we even send any flag with hello saying that I support PIM sticky DR? Because if you see in this current approach, I don't think even any capability exchange is needed, because if there are other routers who don't support sticky DR, if they are not DR at first time, they will never take over as DR, because the whoever becomes a DR and supports sticky DR will start announcing this max value, and this max value will always be honored. So I don't think there is really need for hello, unless working group thinks that there are some cases where announcing option capability option in hello is going to be good. So I think that's all. Can you go to the next slide if I have anything else? Yeah. So if there is any question.
I have just a simple question. Here, you are proposing use sticky DR, or how about your BDR side? If you have another router just come and then have a higher priority than the current BDR, are you going to have the sticky BDR or not?
So I don't think there is a really need for sticky BDR as well. But if there is a real need, I don't see same algorithm working for sticky BDR as well. But in that case, BDR has to, as I said, if we are reserving the range of max value, then BDR has to be less than the DR. That's all.
Okay. Thank you.
Sandy?
Hello?
Yeah.
Hello?
Yeah.
Okay, thank you. My question is, I thank McManus for his presentation, but I think that the contents described in the slides is not the same with the draft. So I'm not sure whether McManus will update the draft to this solution or keep the draft as the same as the exist.
Yeah, thanks for this point. So yes, draft is going to be updated.
Okay, thank you.
Sandy, do you want to directly present yourself?
Yes. May I?
Yes,
Yeah,
please.
we can discuss the combined discussion after your presentation. The one question that Mankamata didn't get answered, however, is the whole PIM-DR max value. Do we need to
I see.
add that?
Yeah.
So
After
maybe we
a
can
short
discuss it at the end.
presentation. Yeah.
Go ahead.
Okay. Hello, everyone. I'm Sunny Zhang from ZTE, and this presentation is for the same background of McManus draft. For PIM-DR improvement draft, this draft has been adjusted according to AD's suggestion since version 10. Next, please. The problem statement is the same with McManus' presentation, but I can repeat it. Maybe you can make it all clear. So according FC 7761, the router has the highest priority will be the DR. So if a working DR or the link between the DR and the LAN fails, a new DR must be elected. Another case is that if a new router with a higher priority connects in a working LAN, the new router will be the DR. So there is packet losing during the switch. Next, please. So according to the problem statement, we know that it makes the network more stable if we can keep DR unchanging. We may also call it a sticky solution, and a new BDR rule is needed. The new BDR can be in standby mode, and it takes over the DR's responsibility in case of DR cannot forward the flow. Next, please. And so the solution defined in this draft introduces two new options in PIM hello message. It's the difference between this draft and the McManus draft. The two new options are DR option and BDR option. This solution will not change the priority carrying function defined in FC 7761. Whenever a router which supports this solution starts to work in a LAN, it should send the PIM hello message with the two options set to 0. When hello hold timer expires, the router receives hello message from other router if there is any. The router checks the hello message from wide neighbors. If it finds that there is DR option set to non-zero value, it won't elect itself as DR even if it has a higher priority, but it still can be the BDR if it has the highest priority among the routers except DR. If there is no existed DR in the LAN, then the router has the highest priority will be the DR. In case there is a router sends the hello message without DR or DR option, then all the routers in the LAN must use the function defined in FC 7761 to elect the DR. The DR will be in standby mode but not forwarding flow until it finds that the DR can't forward flow. Next, please. And so let's see what happened when all the routers start to work in the LAN. All the routers send the PIM hello with the DR-BR options set to 0, and they also send their DR priority. When the hello hold timer expires, the router with the highest priority will be elected, and the BDR will be elected also. All the routers send the hello message with DR BDR options set. Let's see the second situation. There is a working DR in the LAN already. A new router with a high priority connects in the LAN. The new router sends the PIM hello message with DR BDR options set to 0, and it also sends the DR priority. When the hello hold timer expires, the new router receives the hello message with DR option set to the working DR's address. It won't replace the working DR, but it will be the BDR if it has the highest priority among all the other routers except the working DR. Finally, all the routers in the LAN will send the hello message with the same value of DR and BDR options set. Next, please. Once the BDR is elected, the DR will join the multicast tree, but it won't forward the flow until it finds that the DR can't forward the flow. The BDR can monitor the DR by BFD or other detection methods. Next. So this is a summary of this solution. It has a BDR role to reduce the time of multicast tree rebuilding. The sticky DR and the fast switching of BDR can minimize the packet loss. The convergence time of DR election will be 1 hello hold time. The solution has explicit signaling because the two DR BDR options are defined in hello message. And the election result is certain because either the router which has the highest priority is elected when all the routers start to work in the LAN, or the working DR won't be replaced even if a new router connects the LAN with a higher priority. This solution is compatible with AFC 7761, and the function defined in AFC 7761 is used once a router sends hello message without the new option. Okay, that's all. So now I think we can talk about the difference between the two solutions. Yeah, in my opinion, the main difference between the two methods is that PIM-DR improvements has explicit signaling, and the methods defined in BDR draft has no explicit signaling except the max priority value. So I'm not very sure if the max priority value has been used in somewhere, or I'm not very sure. But I think the experience with the deployment will do help with it.
So we have these two drafts that we've adopted as a working group. The idea is valid. We think it's a worthwhile effort to be working on, and we understood the different solutions, which is great. So we either continue to progress these drafts on their own and update them, like Mankamana said he's going to update his draft. I guess the problem is that it seems like there's continuing creeping overlap between the drafts, so we need to try to avoid that. Would the authors of the different drafts prefer to keep them separate?
In my opinion, the non-stacky methods defined in BDR draft is useful, and it can be used in the network, but it has no explicit signaling, but it still works. And the methods defined in existed BDR draft cannot be used because there is many problems with it. I also sent the questions in the mailing list, but from today's Mankamana's presentation, we know that the sticky solution for BDR is changed. So I think only we can discuss is if we whether we use explicit signaling or no explicit signaling. Yeah.
Yeah, I feel the main thing really is that I think we agree that we need a solution for sticky DR, and that's the main place I think where these two, documents both have a solution and they are clearly very different. So ideally, I would like to have a technical discussion, like the email you send it to the mailing list, to find out which method actually is best. What are the pros and cons with each of the methods? Is there a need for both of them, or is one better than the other in some way? But if we pick a solution, then the question is, do we want to have I guess we want to have a draft with just one sticky DR draft, sticky DR solution, right? That the working group picks. Or if you want two solutions, of course, it could be two different drafts. I don't know. But we need to have a technical discussion, I think, probably on the mailing list. But yeah, with all of you authors working on this, I am also wondering though if it makes sense to have possibly merge the documents or have a new draft, whatever, with all the authors together, or that's a different matter. I want to focus on a technical discussion, perhaps on the mailing list.
And I think the time is up now for the slot.
Yeah, thanks, Torvis. I think we need to get going.
But one thing though, we need to get, I think, the draft updated so that we have a good way of comparing the solutions and discussing them on the mailing list.
Yes, I will.
I'd like to say. Okay, please
all right,
go on.
Okay, thank you.
Thank you.
Yeah, thanks. So I guess just quickly, Stig or I will initiate a email on a list, and then please start contributing to that so we can come to a resolution. And Human is up next.
That would be Uman, and he's getting to the mic. Yeah, I think it doesn't matter. Take the any. Yeah, I think that one is better for you to see.
Okay, so this is the point-to-multiple policy ping. Next slide, please. Okay, so just a little bit of update, and I don't know why it's cutting on the site.
Right.
But from draft point of view in this solution, when it comes to the replication segment and the point-to-multipoint policy itself, we are almost done with that work. There are a little bit churn on those drafts. So talking to the co-authors, maybe we start doing last call on those two. On the Yang side, we haven't done any work on it. So, I would appreciate if the working group start looking at the Yang. If they have any comments, please bring it forward so we can start updating those. I'll try to revive that draft in the spring again. But yeah, any comments over there, I would greatly appreciate it so we can have a, good Yang. On the MVPN side, again, we are working on it. I think that's best. We are working on it. We are trying to make the draft complete. I think the next one, I'm guessing, that's the PCE. So yeah, that's 00. The PCE has been adopted. Right now, there are a couple of vendors that are working on the PCE messaging, and that's why it's just stuck on 00. Probably in the next IETF or the one after, we do have some implementation, so there's going to be more churn into that draft. So, some of those changes will come forward on the PCE side. The next one is the IDR, which is the SR point-to-multipoint policy. We just asked for adoption call, and there was some good support. So it should be okay. The last day is actually today, the 24th. So we'll see what happens there. And the last but not least is the pink, which is this draft, which we are working on in this working group. So that's a little update of what's going on with this point-to-multipoint solution from all draft point. Okay, now, oops. I wonder if I did something wrong there.
Yeah, I was just trying to see if I can get it to look better, but doesn't look that way.
I'll swing it.
Is this? Okay,
yeah, next slide, please.
Yeah.
Okay, so what we are trying to achieve here, as everybody knows, when it comes to point-to-multipoint policy and the replication segments, it's a PCE solution. So there is no signaling on the network itself, on the line, on the fibers itself. So it is crucial for us to understand where the failure is within the tree, going from the root all the way to the leaves of this puppy. So basically, the point of this draft is to come up with the OEM mechanism that is capable of testing the tree for each candidate path. Again, a little bit of reminder, on the root, you can have multiple candidate paths that they are redundant, and the active candidate path is the one that has the highest precedence. Any other candidate path is staying there as inactive, and based on the failure, when the PCE or the controller for that matter realizes that there is a failure on the active candidate path, it will switch to the backup candidate paths, if you will. So each one of these candidate paths have a tree of its own through the network. They can be set up accordingly through the network. They can be SRLG, meaning that they can be completely separate from each other. It all comes down to the controller, how they want to set up these candidate paths through the network from the root all the way to the host, to the leaves. So that said, we need to be able to test every one of these candidate paths. Now there's a second concept under the candidate path. And that concept is what we call the path instance. So basically, if a candidate path needs to be optimized, then we can have two path instances under the candidate path, that the second path instance will be signaled through the network through an optimized path, and it can do a make before break procedure on the route to switch from one path instance to the second path instance, so you keep that candidate path up and running, which is your primary candidate path. So this draft will introduce a mechanism to test every single one of these candidate paths and every single one of these path instances under the candidate paths. Next slide, please.
Yeah, let me try to share the application here instead, I think.
Okay, sure.
Let's see. Okay, I need to, let's see. Let's see. Yeah.
Oh, much better. Thank you.
Okay. Yeah. Okay. Right. Okay. So yeah. Are you? But you want to move on to the next slide, right?
Yes, please. Thank you.
Yeah.
So slide 7.
Yeah. Sorry.
Yeah.
Okay. Okay. Here we go.
Thank you. So when it comes to the packet construction and the packet format, we didn't reinvent the wheel. There's already RFCs in there for MPLS NCAP, which is RFC 4379 and 6425. We are basically reusing those RFCs. And I guess one point that I'm trying to make here is that this draft is only for the MPLS NCAP. When it goes to the SRv6 OEM stuff, then there is a draft in the 6-man, which is the OEM for SRv6, and we need to come up with a new draft that reuses the SRv6 OEM packet format to introduce OEM functionality for point-to-multipoint tree in the SRv6 domain, I guess. One thing that we did identify into this draft is the target FEC. So we did identify the point-to-multipoint policy target FEC that identifies this packet to the OEM layer, saying that this is really for point-to-multipoint policy, and the TLV to identify this OEM packet. If you could go to the next slide, please. And I realize the slide numbers are wrong, but my apologies. So yeah, so this is the TLV that actually identifies the packet as a point-to-multipoint policy OEM packet. And there are some questions here that we need to address. I did send an email to the MPLS working group asking that as of now, as we can see, the root address can be IPv4 or IPv6 root address. And as of now, we are using the address family to identify the length of the root address to be 32-bit or 64-bit, depending on whether it's IPv4 or IPv6. So one question is, does it make sense to come up with two different TLVs, one for IPv4 and one for IPv6, and drop the address family? Or one TLV is sufficient enough, and keep the address family, but the length becomes variable in this case. So that's one thing that if you have opinions on, would greatly appreciate if you can feedback to me or to the authors. So that's really the story of what's going on, and and forget about the next slide. Obviously, I'm in a sector too. So that's the update on this draft and all the other drafts. Any comments, questions?
Did that email go to MPLS and PIM or just MPLS?
Good question. I replied to everybody on the last email, so it should have gone to PIM. I'll double check.
I'll double check as well, but thank you. We'll respond, or hopefully they do actually.
Okay.
Thank you.
Yeah, I see we have the same problem with the next slide, so I'll share a window again. Let's see.
So probably it's the way I printed out then, because I just
Yeah,
grabbed PowerPoints and
actually.
I print. So maybe I did something wrong there.
Okay.
Okay, so the next one is PIM Lite. Basically, what I'm trying to achieve here is to have the working group to come up with a baseline for this draft. There was a lot of conversation, emails back and forth on the working group email list, which is great. But I think we need to agree on the baseline and what do we want to do here, and based on that agreement, take it forward and see what we come up with. So next slide, please.
Yeah. Let's see.
That's very strange.
Yeah, let me try to fix this just a moment. See. Yeah, let's do it this way.
Thank you.
So, yeah, sorry. Let's see.
All right. So a little bit of history. This draft, this idea came alive when we were doing the last car for beer PIM signaling. Basically, in that draft, what we wanted to do was to send the multicast state, join and prunes from one beer edge router to the next beer edge router. And in the draft, we had explained that we are only sending joins and prune messages as a signaling from one B router to the next one. And then the question became that since these packets are very close or identical to PIM joins and prunes, maybe we need to identify a brand new PIM interface that could carry only the PIM joins and prunes without actually trying to bring up a PIM adjacency between the routers or two peers for that matter. And that's where the idea was born. So basically, we are not trying to complicate the story here. All we are trying to do is send multicast states or remove the multicast states between two PIM routers that are attached either directly or via some medium, and that medium can be anything. It could be beer, it could be any other medium. And then the next question is if there is no hellos, because we are not bringing up we are not sending PIM hellos, it's just the states, then some of these messages like asserts or some of these other messages that are really relying on the hellos might not get accepted or processed by the PIM routers accordingly as well. So next slide, please. Yeah, so basically, again, as I explained, as of now, depending what happens in this meeting, the entire idea was just to come up with a new interface, whatever we want to call this interface, that only is capable of sending a couple of messages, including joins, prunes, and maybe asserts, and to have the other router accepting these messages, even though the fact that there is no PIM adjacency or the PIM hellos between the two routers. Next slide, please. So there were a couple of, well, not couple, there were a lot of discussions in the working group, which I'm bringing up in this slide. So just to refresh everybody's memory, one thing was the name. Some people didn't like light. Some people were saying it's light, transit, etc. So we need to come up with a name. And the next thing is there were conversations again, if we can use hellos from other type of protocols like IGP to revive that hello messaging between the two router. So even though we don't want to send the PIM hellos on this specific implementation, can we kind of piggyback on some other type of protocol to make sure that the two PIM light routers are still up and running and communicating with each other, and there is some kind of heartbeat between them, I guess. The next question was, as of now in the draft, I mentioned that when it comes to the joins and prunes and asserts, those are the type of messages that are accepted when there is no PIM hello. So, one question was, do we really need assert in this type of scenarios, whether there's going to be duplicated traffic, and if there is duplicated traffic, whether assert is the way to go to actually avoid that duplicated traffic. There were other comments with regard to the multicast state that we need to identify the states that we want to signal over this medium, SG, star G, etc., etc. And the last but not least was, what is the interface itself? If it's PIM Lite interface, do we need to explicitly configure this interface because of security point of view, and do we need to only accept the joins and the prunes on medium that has this interface connected to it? And if so, in some of these mediums like beer, you cannot really create an interface. So what do we want to do there? Yeah, so I guess we were hoping for a quick, dirty way of identifying this brand new interface and making it use in the beer draft, but it might be that we created a bigger hole, which we need to kind of figure out what we want to do here. So I think I'm going to pause on this slide and let it digest. And, if there's any comments or questions, now is the time.
Torlis has one for you.
Yeah, so my recurring wish that I don't get for 30 years now. So if we have an upstream interface with multiple possible senders of traffic, and what we're doing assert right now, we've termed a strong RPF to be able to filter out the packets based on who sent them. We never did this because that's layer 2 filtering, right? You would need to know which of the upstream PIM routers would send something. But for example, in beer, we also have that, right? We have the beer BFR ID in the header. So even on a beer side, we know who sent it. Whether you call that strong RPF or you have a virtual interface on a per upstream BFR ID, and you're effectively, changing your RPF interface so that you at the PIM level representing not a LAN, but for every upstream BFIR, a separate point-to-point interface. I mean, that's a modeling question, but in the forwarding plane, you obviously want to receive a packet and filter it based on the BFR ID in the packet. If the vendors think that can be done, I'd be very happy because that would get us rid of assert, but I don't believe that'll ever happen.
Sure.
So Stig here. So with beer, you don't have a shared medium, right? So asserts wouldn't work anyway. If some other router is forwarding something, you would only receive it if you actually had asked to receive it, right? So so the concept of assert only really works if you have like a shared medium, like an Ethernet, or somehow simulating that. So I think it should be possible to say that this PIM-Lite mechanism doesn't support assert, but it's restricted to certain types of links or interfaces. That's also why you don't need the DR priority, DR election, right? For these other questions, I don't see a problem with an RP. An RP doesn't need to anything in particular when it comes to neighborships. And for the interface being enabled, I think it's fine to say that certain interface types, say like a beer interface, it's enabled by default.
It's enabled by default. Okay, yeah, got you. Okay.
So I think most of these can be dealt with pretty easily. Just need some text explaining exactly what the applicability is of the PIM Lite. And
Okay.
explain why we don't need to worry too much about asserts and some other things.
Okay. Okay, so that sounds good. So maybe, oh, there's another comment, sorry.
Sandy. Go ahead, Sandy.
Hello. 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 Do you hear me?
Yeah.
Hello. Okay. I do support the motivation of this draft because I think the PIM over beer deployment may be very widely used in the future. So I do support this draft, but I think the last discussion is very useful and some details must be added in the draft, right? So it will make the implementers more clearly about the solutions. Yeah. About the name of the PIM Lite interface or something else, it doesn't matter for me. Yeah.
Okay, thank you. Okay, so maybe the way forward is we'll wait one more IETF. If everybody can ponder about this slide specifically, and based on the emails that we receive, we'll update the draft. And in the next IETF, we can do another presentation and see whether we can adopt a draft or how to move it kind of forward, kind of thing. That's where I am right now. I think in the next. Sorry, can you go to the next slide? My apologies. Yeah, so I think from what I'm hearing, there is somewhat of an agreement. We need to put a little bit more meat into the draft, which is fine. I'll work on it. Send your comments into the what we just discussed. So I'm getting old. I might forget some of this stuff. So please send it into the email, working group email. I'll put them into the draft, and next IETF will take it on.
And we certainly don't need to wait to the next IETF unless you want to. Sandy can certainly initiate an adoption call on the list.
Okay, appreciate it. Thank
before
you.
Then, yeah.
Okay, thank you.
Hongji.
Hi, Mike. Can you hear me?
Yes.
Yeah. Okay. Hello, everyone. I'm Hongji from Ericsson. Now let me introduce a new individual draft about HMP snooping young model extension for L2 VPN. Next, please. And this is the first version for the presentation, and the effort is from the Monte Carlo Young design team. The authors are from Ericsson, IBM, Juniper, and China Mobile. Next, please. Let me introduce the relationship with the RFC 9166. The RFC 9166 defines the young data model for configuring HMP and MLD snooping, but it only covers the HMP MLD snooping in the bridge service. And this draft was published maybe February this year. It's just published. Next please. This draft was this RFC was HMP snooping young model draft, and it once included the L2VPN part for HMP and MLD snooping, and entered into the RFC edit queue in August 2020. But it was blocked in the misref state more than 1 year because of a normative reference to the IETF best L2VPN young. In this draft, it defined the L2VPN model, but this draft has expired on maybe January 2020. It is not an active draft now, so we ask for work group last call in the PIM group working group for removing the L2VPN part in September 2021, and it passed. So we removed the L2VPN part for this draft, and not long afterward, this draft was published as RFC 9166. Next, please. But we think that the HMP MLD snooping could be used in L2VPN service, so we think it is still needed to be covered in the young data model. So we make this new individual draft, and all the authors are the same as the authors of RFC 9166. Next, please. Now let me introduce some details of this new individual draft. First, the mRouter interface for L2VPN. In L2VPN, there are two types of mRouter interfaces. They could be called the AC mRouter interface and PW mRouter interface. We could manually configure the mRouter interface AC or PW, and we could also these mRouter interfaces for L2VPN could also be learned dynamically. When they are when the mRouter interfaces are dynamically learned, and they are read-only. Next, please. Second, and there are also two types of outgoing interfaces for L2VPN. We could manually configure the outgoing interfaces under the HMP snooping instance. They are AC and PW. And next, please. Similarly, these outgoing interfaces could also be dynamically learned. They are read-only. Next, please. Now, in order to use the snooping instances in the L2VPN, the HMP snooping instance and the MLD so in order to use the snooping instance in L2VPN, we augment the network instance whose type is L2VPN, and the instances could be referenced in the L2VPN service, like below. That's all the all the updates of that's all the key points of about this individual draft. Next please. And next step, we would like to apply for the working group adoption, and welcome any more comments. Thank you. I see.
You want to go first, I guess.
Sorry.
Mike, did you have any comments?
Say that again.
No, I was just waiting for you.
To do
You go
what?
first.
Oh, the call. No, I don't have a question. I was just gonna initiate a adoption call on the.
Okay.
show
Well,
of hands.
okay. So one question: the LTVPN draft that we were waiting on, is that progressing now?
No, there's no progress now. The latest version is has appeared at in January 2020.
Right.
Mm.
So it means that if we move forward with this, it will get stuck again, I guess. But I still think we should move forward, though. So the contents of this draft is basically exactly what we agreed to publish before, right? Is the content of this draft exactly like the model that was in the previous draft, right?
Yes. Yes.
Yeah. Okay. Yeah. Thanks.
So right now we do have 10, 11 who are showing adoption agreement for this draft, Hongji, and none against. So I think that's fairly conclusive. We'll send an email as well. We're up to 12 now. But I think you can safely assume that we will adopt this draft. So for the record, we're at 15 right now in favor and none against, and I'm going to go ahead and end the session. Thank you very much.
Right. Thank you.
Thank you.
Okay, let's see. Next.
Isong.
Let's see.
Hello?
Go ahead. Go ahead. Yep. Yes, go ahead, Isong.
Okay. Hello, everyone. I'm Isung from China Mobile, and today I will present the PIM-MFR based on the TRFA. This is the second time to present this draft. And the next slide, please. Firstly, I will give the brief introduction of this draft. And as we know, and the PIM-MFR is a very important protection mechanism for the multicast deploys. It can minimize the packet loss when the failure happens to the multicast parts. But in the RFC 7431, it can only use the LFA, but LFA can only cover part of the network topologies. So there are some kind of the topologies, and it cannot cover. So, and the TRFA can help the unicast FR to achieve the almost 100% network topology coverage. So we in this draft, we provide a new mechanism by using the TRFA for the PIM-FR, and it's no need for the additional extension of the PIM protocol, just to use the existing PIM features. And this time we update the draft as an informational draft, and that is a recommendation for the multicast protection deployment in the SR networks. Next slide, please. Sorry, I can't see the slide. Oh, okay. The firstly, the MFR based on the RFA that is has defined at the in the RFC 7431. So the ability to build a backup multicast tree just according to the normal protocol procedure of the RFC 7761. The next slide, please. And we come to the RFA, and the PQ the PQ node for the RFA, and for the unicast it will establish the unicast tunnel to protect the unicast traffic. So the PQ node we can use the PIM RPF vector attribute. We can look the PQ node as the first part of the backup multicast trees route. So firstly, we can build the first part of the tree, and when we when the PQ node, like the example, R3, and it will remove the vector, and then it will establish the multicast tree according to the multicast source directly. Next slide, please. So this is the TRFA for the unicast FR in the SR networks, and the draft TRFA has defined the solution, and the unicast traffic can be protected according to the SR repair list. And for the example in the picture, the repair list including the a node seed from the P node and the adjacency seed for the P between the P and Q. So we can get the second list to protect the unicast, but how to use to the PIM join. The next slide, please. Fortunately, we have defined the PIM features for the RPF vector attribute and the explicit RPF vector attribute. For the node seed, we can use the RPF vector attribute, like the R4 in the picture. For the R4 in the vector, we use the type 0 of the join attribute, and it will look up the unicast routing to the R4 and hop by hop to send the PIM join from the R6 to R4. And the second vector is that the explicit RPF vector attribute, that the type 4 of the join attribute. It will it will not look up the unicast routing table. It just specify the PIM upstream neighbor. So when the PIM join received by the R4, and it will check the type 4 attribute for the R3, and will directly send the join to the R3. And after the PIM join received by the R3, and it will remove the vector, and in the join packet there is no vector now, and it will continue to establish the multicast tree to according to the RPF of the multicast source directly, and hop by hop to establish the remaining backup multicast tree. So that's the method of using the SR repair list to establish the MOFR backup multicast tree. Next slide, please. So that's all. And any comments?
Thank you, Isong. Is your goal to continue to work on it and then, oh, sorry, Human, go ahead.
Yeah, just one question. I wasn't clear. In the slide that you're sending the joins, are those going over the segment routing, or are they just like going over interface?
Oh, just going over the interface. It's just use the segment routing as the segment list as the reference to the RPF.
Okay. But then the part I guess I'm still confused is when the traffic comes from R6 and goes to R5, and if the R5, if you are not tunneling the traffic and the R5 says that, no, this is not the best path, go back to R6, how are you mitigating that issue? Like, how are you going from the P space to Q space without the P space sending the traffic back to R6?
Oh, this also according to the PIM protocol, and the hop by hop we will build the PIM state for the SG.
Okay,
R6
so
will send the join to the R5, and R5 will create the SG state. And
okay.
also for the R4 and R3.
So basically what you're saying, the multicast, I guess part I'm confused about, the multicast traffic is never going over any SR tunnel. It's just being forwarded.
Yeah.
Okay, thank you.
Multicast the traffic never to the SR parts. Yeah.
Niels? Is there a question?
Can you hear me now?
Yeah.
Yeah.
Okay, great. Yeah, I also have a question. From my understanding of MOFR, this is a live communication. So you will receive on R6 the streams twice. So I don't know if I'm just thinking too far out in your example, but looking at the example that you've given here with low bandwidth routes, this this really seems a bit like constructed. Is there a real life demand behind this, or is this more of a theoretical and educational RFC?
This is a information of the information draft, and we just recommend this mechanism in the SR networks. So if we use the PIM, traditional PIM for the multicast.
Okay. Yeah. Okay. Thanks.
Okay. Thank you.
Stig may have to make a call on this draft going forward since I'm on this draft.
Right. Yeah. Yeah, so the draft looks interesting to me as well. I wonder. Guess we can do a call. I wonder whether whether people understand well enough what's in the document or not. But maybe most people have read it and get it. We can try a poll and see.
Do you want me to do that, or are you doing that?
I can.
Okay.
Yeah, maybe you can do it.
Okay.
I'm trying to figure out how here, but yeah, I'm a little under the weather today. So.
Yeah. You're a hero for being here.
Oh.
Do you guys see the results like I'm seeing it?
I'm seeing it at least as it's counting up.
Can a non-chair see what I'm seeing?
I'm guessing not. It's not fair if you can see it, right? Before
Maybe
you
so.
vote. I would think, but I don't know.
Maybe so. Yeah. Well, right now we've got 14 that have raised their hand in support and one against.
Good. Yeah.
So.
Yeah. So. Well, there's definitely a lot of interest, but yeah, I see we have, a couple of people against as well. So I would say we need to take it to the list. We need to understand, why some people are against it as well, and also possibly why people support it. But at least we have a lot of interest, so we should definitely go ahead and do an adoption call on the mailing list.
Yeah, so just for the notes from when I do it, right now it's 15 in support and 1 against, and I'm going to end the session. Great, thanks. Now we have a few drafts, and it looks like we've got a decent amount of time here that all have something to do with point-to-multipoint SRv6 and related ideas, and so Waymo is going to be the first one. He's just getting back from presenting in another working group, so he's a hero for getting here quickly.
Yeah, I'm here. Can you hear me?
Great. Yep, thanks.
So hello, everyone. I'm going to talking about multicast using multicast routing head. Next page. The existing solution based on SR include SRP2MP policy, and our previous draft SRv6 pass, which we have received lots of comments from the working group. So these existing solutions have some weakness. And the multicast using multicast routing overhead is a good alternative, which takes these comments into account and also is more scalable. Next page. So basically, each link of a node have a link number, which is local. Each node in the network have a table. This table maps link number to the next hop address of the link. A multicast tree is encoded by link numbers. The ingress of the tree encaps the multicast package into a multicast routing header for each subtree from the next hop of the ingress, and then send the package to the next hop. And then finally, the package will reach to each of the egress node. At the transit node, after the transit node receives the package, transit node just gets each of the link numbers from the multicast routing header, and then find the next hop address from the link number from the label table, and then send the package to the next hop. At the egress node just decap the package and then send the package to the IP multicast forwarding module. Next page. So this is the basic encoding of a multicast tree. We just encoding the tree, every link on the tree, and then each link from node U to D is encoded by 3 fields. Link number field indicates the link number on node U. The number of branches is the number of links from node
sorry,
D.
Raimo, we lost the slide stick. Can you refresh?
I refresh. I can see the slides.
Okay, there we go.
Is this the right one, or?
Yeah, I think you go.
Let me see. So
Yeah.
the slide.
The next
and
one.
Then the
Page
basic
4.
idea.
Page 4. Yeah, page 4. Page 4. Yes.
Ah,
And then
okay.
the third. Not the previous one.
Previous.
Yeah. No, the previous one. Page. Yeah, this one. Page 4. And
Okay.
the third field is a pointed to the subtree from D. So, for example, for link from ingress from P1 to P1, the link number is 2, and then the number of branches from P1 is 4. We have 4 links from P1, and then the number 22 as a pointed to the subtree from P1. So next page. So for the egress node, for the link to the egress node, those number of branches and the pointer are all zeros. And then we can introduce a flag L to indicate this link is to egress node, and then we can remove those 2 fields, number of links and the pointer to the subtree. So in this way, we can reduce the overhead. For example, after receiving those 2 fields for the link to the egress node, we can use 16 bytes to encode 14 nodes tree, the tree with 14 nodes. So next page. So in addition to that improvement, we can also remove the link number field using a bit set 1, indicate that the bit number will be used to encode the link numbers from node D. So for example, we have subtree here from P3 to P4 to PE4 to PE7. So those links from P4 can be encoded by bit strings. And also we have a P flag indicate that those nodes, in addition to represented by the bit number, and also indicate that the next hop is a leaf node. So in this way, we also remove the L bit in this case. So in this way, we encode the subtree here just using 4 bytes. So next page. So this is another example to use the bits to encode part of the subtree. So this in this way, we just when bit is used, and then we also remove the link number field. So we further improve the encoding. So next page. So we come together, we have encoding for a whole tree. So we use 13 bytes to encode the whole tree. So when we use this one, and then we ingress node, we just includes the subtree from P1. So in fact, we only use 11 bytes to do the forwarding. That's the overhead. Next page. Multicast routing head. The multicast routing head is a routing head with a new routing type. This header is similar to segment routing header. It will contain a subtree from a next hop. And then we have SL will point to the subtree. We have field MB, which is the number of branches or number of links. And then we have bit to indicate whether the bit string is used for the links from next hop. On the ingress node of a multicast tree, we'll encap a package in a multicast routing header for each next hop, and then send this one to the next hop. The multicast routing header will include subtree from next hop, and then the ingress node which just set the fields such as SL, MB, and B in the multicast routing header to the corresponding value for the link from ingress node to the next hop. For example, here, MB will get the value from this cycled one, which is a value corresponding to the link from ingress node to P1 next hop. And then just send this package to the next hop, which is P1. Next page. So after P1, as a transit node receive the package, so it will send a copy to each of its next hop. For example, for next hop P2, P1 just sets the fields B, MB, and SL in the header to the corresponding value for the link to the next hop, and then deliver to the next hop. That's very simple, without any modification inside of the tree included in the header. For egress node, for example, from P1 to P8, which is the egress node, we just set SL to 0 and then deliver the package to the egress node. After receiving the package, if it's a egress node, which is indicated by SL equals 0, egress node just decap the package and then send the decap the package to the IP multicast forwarding module and done. So next page. Yeah, I think this is a very straightforward and simple. And then I would like a comment, and also, if possible, I would like a request an adoption call.
As a individual contributor to this draft, it would also be helpful. This will probably be something that we need to discuss, of course, further on the list. But Bob Hendon did mention to us that so Waymo presented this in 6-man as well this week, and Bob mentioned to us that the header format and processing would be okay for 6-man to discuss, but the whole notion of the this multicast routing header that Waymo's described would be better in a working group that's focused on multicast, and that's why he's presenting it here. So if we were to ever take up this draft, 6-man would then work on the actual processing and the header format. It probably would be kind of similar to what Human did very successfully with his point-to-multipoint draft, and having a replication segment defined in Spring, and then the stitching of all those segments in a policy done here. So it's kind of a rough equivalent to that. So just wanted to throw that in there. But you're going to have to drive this Stig.
Right. For this, I feel like we probably need people to, give people some time to read it carefully. This is all new, right? So I suspect not too many people have really studied it yet. Yeah, I would say let's follow up on the mailing list and try to have some discussion there. It would have been nice if we could ask how many people have read it, perhaps, but I don't know if it's worth having a poll just for that.
Okay, I'll do that. And Robin's got a question.
Okay, sure.
Okay, Robin from Huawei. So my comments is that the later we will provide some of this comparison between the this solution and the previous this solution. Yes. Yeah, previous this P2MP, that's the SR solution that dropped is also to encapsulate the P2MP tree. Okay.
Right, you're right. So there are a couple of different solutions here, right? Yeah. So we may have to give it some time to, have people understand all the different options.
Yeah.
So 10 people have indicated that they've read the draft, and 5 indicated they have not. So there you go.
Yeah.
I'll end.
Okay, thanks. Yeah, I think let's get all the all the potential solutions first, and then we need to discuss them a bit more carefully to find out which solutions look the most promising. So I would say let's just continue discussing the draft on the mailing list. But we should work towards evaluating the proposals and finding out which solutions look the best. Torles?
Oh, I'm just waiting to present.
Right. Yeah. Let's take it to the list, and Torles next. Yeah.
Can you still share the slide? So I'm not sure that.
I know you can easily do it yourself, but I got it here now.
Yeah. Okay. So presenting alternative option, but whether they're exclusionary or amend each other, I think that's another interesting question. Next slide. Okay, so what we want to have is a native IPv6 SRv6 solution for point-to-multipoint that is stateless. Homan already done all the work for the stateful ones with the replication segments. So this is intended to be part of the SRv6 architecture for networks with only IPv6 and SRv6, so where the operators do not want additional layer 3 forwarding planes for multicast that are not IPv6. And we want this as much as possible to be, well, as little changes over, what we're doing, let's say with the SRH header for path, but just the same thing for multicast replication. And there is no such solution in the IETF today. It's unicast only SRH, but we already saw one other proposal to do this. So, in this proposal, the core property is really of the encoding of the compressed tree, which we call recursive bit string structure. Next slide. So the recursive bit string structure is shown on the right-hand side. That is in the blue box, the whole address structure as it is seen on the first router A. And that router A simply needs to examine a single bit string that is indicating the adjacencies on that router A to which it should send packets. So in this example here, it has 4 possible adjacencies. 2 of them have set bits, so that is an adjacency to B, an adjacency to C. And so what router A needs to do is simply do a lookup of these bits in the bit string. And then for each of the copies, the new work is that it needs to rewrite that compressed address so that only the subtree for that particular neighbor is the active address for that copy being sent. And active means it could be rewritten so that everything is thrown away except for that subtree, or it could be pointers that basically say here the active part of the address is just that subtree. And that is, I think, a little bit also the question with 6man, because shortening an address is something that is not officially endorsed by RFC 8200, but it's also not prohibited. So we're fairly, not opinionated on that, but let the IETF decide what would be best. Next. Okay, so why do we want this? So all these wonderful traffic steering things we can get out of that, right? So the prerequisite for guaranteed resource path with bandwidth and latencies when we have a PCE and admission controller. It's great for the path diversity with the zero loss multicast, for DetNet with pre-auth. It's great for minimum cost Steiner trees, capacity optimization through non-ECMP load splitting, which is pretty much today in unicast 95% why customers are using segment routing. So the ability to engineer these paths in multicast trees would then also mean that you can utilize the capacity in the network for multicast equally better as you can do with segment routing for unicast. And then, of course, also, and that's maybe even more going back to the original roots, predictable and simple convergence. There are no micro loops that we're getting with the hop-by-hop reconvergence through the IGP when we're not doing source routing. So now that's all traffic engineering that we get through the traffic steering of indicating the tree. But even if we compare it to just flat bit strings that are not encoding the whole tree, we do think we get scalability benefits. And those come simply from the consideration that this working group and the original protocols we did, right, PIM sparse mode, kind of our biggest success, is based on the predicate. We've got a large network and the multicast delivery tree is small. So we're only sending to a relatively small number of receivers in a large network. And so there's the simple thought example without a good picture. Consider you have a network with 2,560 destinations, egress PEs and the service providers. You have flat bit strings of 256 bits, which is kind of some existing technology. And you want to send to 10 destinations. Well, if you have flat bit strings, you might be unlucky and you send 10 packets because all these 10 bits that you send to are in 10 different bit strings. So your replication efficiency is sent to 10 destinations. If you're lucky, it's 1 packet. If you're unlucky, it's 10 packets with flat bit strings. And if you use this RBS scheme in the validation topologies that we used, you can get always away with a single packet because you can always encode for any combination of 10 receivers, any tree within just less than 256 bit of RBS tree. So even RBS does encode the whole tree. It is, in our opinion, even more efficient in many cases than any flat bit string option. And of course, that example did not even include the overhead of encoding the tree in flat bit strings. So, so we think that this recursive bit string structure is, of all the proposals, the best compressed version that gives the best replication efficiency. Next slide. So here again, in a little bit more detail, hopefully that can be read. It's a little bit too small for me, I guess. Here, hopefully it's better on the large screen. How do we encode and process? So all the length fields that we're using are in bits so that we're efficient. If a router has n neighbors, then the bit string to be examined on that router has n bits. So in our example, we had 4 routers. So we have a FIP with 4 RBS, which we see on the right-hand side, which has 4 bit entries. Each entry has the address of the next hop, which is what, in the usual segment routing fashion would be the destination IPv6 address in the outer header being replaced. And then we have another column that says whether that particular neighbor is a leaf or it's an intermediate hop. If it's an intermediate hop, then it means there is a recursion field, and that's shown here in the middle. In the address, there is a subtree for that particular neighbor, and that is then what's going to be extracted as the address to the neighbor. If a neighbor is a leaf, then of course that neighbor doesn't need to get any further address, but the packet can just be sent to the neighbor without any further RBS address. So as far as processing is concerned, single flat bit string lookup on every node, and then an address rewrite, which is adjustment of pointer or extraction of a part of the address and making that the address. So we also think this is the least amount of complex processing in the forwarding plane of any of the compressed options that we have seen. Next slide. So, and here again, the comparison with the segment routing header for IPv6, right? So the idea, of course, is architecturally and operationally the same. We're just doing replication. And for that, we're carrying a segment tree as opposed to a segment path. Yeah, so in Unicast, we had one uncompressed solution, and then it just took us 8 years to start working on the compression there, which is what we're doing right now in 2022. And so hopefully we can, for the multicast part, skip all the, bad compressions or uncompressed options and directly go to the best possible compression. The forwarding is the same, right? Segment by segment forwarding by swapping the IPv6 destination address from the forwarding information that I showed. That's from the FIP, so that we have compression in the packet, just bits for the neighbors, and then in the FIPs, the next hop IPv6 addresses. And of course, yeah, we're replicating more than once. That's the whole point of the multicast. There are TLVs in the SRH headers optionally for egress node functionalities. We would think that we start saying we have the same set of TLVs, but we'll have to work through which of these are applicable for multicast packets equally. So that's some TBD work. SRH also has the programmability in the uncompressed version. When you have long addresses, we haven't seen use cases for these transit hop programmability functions, so we haven't considered that yet. But if that is desirable to have, then we can look into this. But right now it's maximum compressed, so no programmability on the intermediate hops. Next slide. Right, so then the next steps, and Mike was already alluding to this. So assuming that there is a community across Spring and PIM that wants to adopt this, we may need to figure out how to split that work between the working group that kind of understands the multicast technology, which would be PIM, and then 6 men for anything that relates to the RFC 8200 IPv6 extension header encoding details to make that compliant. So maybe there needs to be some type of an architecture document equivalent to RFC 8986, which is the SRv6 architecture, also for the multicast part of it as an extension to the SRv6 architecture, and then the extension header maybe as a 6-man document. I think as soon as we see sufficient support for the technology, I guess across the working groups, we're going to figure that out. And then, of course, the question is, do we want extensibility of the compression mechanisms in terms of not fixating only on one. Of course, as here, me representing RBS, I think that's great. Is it sufficient? Do we want to be future-proof by having options for multiple compression algorithm? That's, I think, another important technical question that we should maybe look into more simulations of performance across the different mechanisms to make decisions on. And I think that's it. Next slide. Yeah, please show your interest. I think PIM working group should be great to get the discussion started.
Robin?
Okay. Robin Huawei. Torres, in fact, you know that's the one advantage of the SRv6 is the incremental deployment based on the existing IPv6 network. I'm not sure this mechanism if this mechanism take the incremental deployment into account or not, or the mechanism need to upgrade the whole network to support the RBS. So I think this may be a challenge for the deployment, especially for the existing network.
Right. So the answer is that it can definitely work incrementally. You only need to support RBS on the nodes where you want replication to happen. But at that point in time, what you need to do is to define the FIB with the adjacencies of not directly connected next hops, which is exactly what you would be doing with loose source routing in the unicast case as well. And that will work perfectly fine. But of course, you may have more adjacency bits then, because you have just, let's say, 4 physical links. So that's just 4 bits in a fully upgraded network. But if you go 2, 3, or 4 hops, you may need to have more bits there. So the performance, as far as how well is it compressed, for the incremental update case is another good performance evaluation that would need to be done.
Okay, my second comment is that that's the this in fact the multicast solution may be more complex than the unicast. I think this is the good practice of SRv6 is to provide some of this the Euler suggestion for the SRv6. So I think maybe in the draft, maybe more Euler suggestion can be provided, or maybe there's an additional Euler suggestion draft accompany this draft for better understanding about this solution.
Yeah, so I think right now I think also all the other drafts have only started to think about is the basic forwarding plane mechanisms. And as I said, we may even need to split up that type of work between something to go to 6-man on the encoding side and the architecture in a similar way that we had it in Spring and in 6-man. Yeah, none of this covers the control plane parts of it, for example. So this is just the core from which that work is starting, right?
Yeah, to me it seems reasonable to do an architecture document, and that's something that can move on without having decided on the exact solution, right? That's independent of whatever encoding we end up with.
Yes, I think you have the right strategy right here on this slide, Torlis, is to take this discussion to PIM. I think it's the right place. Since you are defining a new type of segment, right? that part would likely need to be discussed in spring. Kind of like the replication segment is something that's done in spring, but Stig and I can help figure that out as we progress. Does that make sense?
Yep.
Okay. And we need to move on to the last presentation. We're right on time. Thank you. So Shushang.
Hi. Hi, can you hear me well?
Yes.
Okay, thank you. This is Xu Song from Huawei, and I will introduce our work about multicast source routing over IPv6 traffic engineering solution. Next slide, please. Here is the problem statement. Basically, SRv6 has already provided a solution for unicast service to indicate P2P pass through segment list in SRH for TE scenario. And there is no flow status is requested to maintain in the intermediate nodes, which is very beneficial for deployment. And also there are several SRP2MP solutions under discussion for multicast TE besides the previous two presentations. One of them is what has already been discussed in PIM for a while, SRP2MP policy solution, in which SRP2MP tree is constructed by sticking a set of replication segments together through SRP2MP policy in each replication node, which will introduce a replication status in the intermediate nodes. And another solution is previous work from Huaimo, which is called SRv6 P2MP pass. A segment list for P2MP pass is provided to the ingress node, and there are two arguments for each seed, which is n branches and n seeds to indicate the next level of subtree after replication. And for this document, we will provide a optional solution of multicast P2MP pass indication for multicast TE. Next slide, please. Before going to the detail of our solution, I think we can briefly review what has been done in SRv6. In SRv6, if there is a client packet from the CE side, in the P side, the ingress node will encap the packet with IPv6 header and SRH. And in the SRH, a segment list will indicate the P2P pass. And in the endpoint, it will update the segment left by segment left -1, and the destination address is replaced by the next active seed pointed by the segment left, which steers the packet to the next indicated node or adjacency in the TE path. This is based on the behavior definition for the function of AND or AND dot X in RFC 8986, and in the egress node, when the segment left equals to 0, the packet will be decapsulated and forwarded to the CE side. So that is the unicast method. So what can we do for multicast? Next slide, please. This is our first solution. We introduce a structural segment list for multicast tree. The basic idea is that we can define a new function type, which is called AND dot replication through segment list for specified nodes which the multicast tree passes through, and define two parameters in each seed, which is called replication number and pointer, to indicate the replication and forwarding relationship between the upstream and the downstream nodes. So what does solution look like? First, there will be a segment list just like the unicast. The segment list will contain all the seeds according to the indicated nodes in the multicast tree. For example, in the picture in the right hand, there is an indicated multicast tree, and for each node there will be a seed in the segment list. In multicast routing header, we call it MRH. And in each seed, there will be 3 parts as the segment format, just like the unicast SRv6 seed. There's a locator, there's a function, and also 2 arguments. One is replication number, which could indicate how many packets to replicate in this node, and another is a pointer to indicate the segment left value of the first child node. The basic idea here is that if it is a P2P pass, the problem is very simple. We just set the segment left by segment left -1, but if it comes to the multicast, the next hop downstream nodes will be a group, and we cannot find the next seed only by -1. So we have to indicate how many packets will be replicated and where to find the corresponding seed. So we define these 2 arguments, and so correspondingly, the behavior is the packet will be replicated based on the replication number and update the segment left and the IPv6 destination address based on the pointer, and forwarding the replicated packets to the downstream nodes. Next slide, please. Here is a simple example, and I think I won't go to detail. Maybe if you are interested, you can see the whole progress here in different nodes. Next slide, please. And we can see in the previous solution, the drawback is also very obvious, because if we have to allocate a seed for each node in the multicast tree, the header expense may be unacceptable when the tree is large. So we introduce some compression method to with local bit stream. The basic idea is like we define a local bit string in each seed, which each bit represents a local outgoing port, and if the packet is supposed to be replicated and go through that outgoing port, the corresponding bit position will be set. And with the local bit stream, the multicast seed for leaf nodes can be saved in the segment list, so the header expense can be reduced. Next slide, please. Here is a very simple example, and you can see only 1 seed is needed in a tree like this, at least. Next slide, please. Here are some additional thoughts. Actually, a new type of IPv6 routing header for multicast, which is called MRH, is mentioned before, is proposed. And we think this MRH is requested for different types of encoding P2MP paths. Maybe including the previous presentations and other possible options. And so maybe we think more contributions are needed to make this header reasonable enough and be able to compatible with various encoding forms. So, and also maybe cooperations with Sigma will be very helpful. And here is a very simple comparison between 2 existing documents, which are very similar. One is recursive subtree, and for the former, and another one is the layered replication behavior. And the first one will pops the irrelevant segments after replication, and the latter keeps all the segments just as SRv6 does for unicast, and segment left is used to locate the active seed. And for the local bit stream method, the locator could be omitted, considering that local bit string is able to indicate the next hop IPv6 prefix besides the output port. And this method is also introduced in detail in our document. If people are interested, maybe you can go for it. This will compress the header further. And also the different kind of solutions can be combined together to be used. And if the seed is too long, and the segment can also be considered to be compressed as what has been done for SRv6 and SRH. Next slide, please. So we hope more people will be interested in this work because P2MP path encoding can be complex but interesting and with a lot of possible solutions. So we think more work can be done here. And for our document, comments and feedback will be very welcome. And for the concept of MR6 and based on IPv6 network, we have already proposed above. And if people are interested in this topic, maybe not only in PIM and relative working group, we can also discuss in above. Okay, that's all. Thank you.
Thank you. Appreciate you presenting. Any questions for Shishong? I think we have quite a lot, Stig, to discuss on the list. Robin has a question.
Yeah, me too. Yeah.
Okay. Robin, again. So in fact, these solutions propose this the multicast routing header, but I think that's this a little different from the SRH, because the SRH only one routing header, but here, because this is the different mechanism, that all this mechanism needs the new multicast routing header. So the first we think we should think about how to converge this solution. The second one, we may think about how many types of MRH we need. If more types of the MRH routing MRH are necessary, so we need to synchronize it with the CXMAN. So that's my comments on this one.
Thank you, Torles.
Yeah, just to respond to what Robin was saying there. So the proposals here are saying that we could basically just take one code point for the routing header field space and then do a different subtypes for different type of encodings and so on. Actually, the space is rather large in terms of 8 bits and not many values being used there. And for example, in Unicast, we actually have 2 source routing headers already, at least that I remember, because the IoT space has also done its own one, and not only the Spring working group, and they simply took 2 different values from that 8-bit space. So we already got evidence that if there are multiple different options required for different use cases, then you may not need to sub-multiplex, but you just get 2 different or 3 or 4 different code points there. It doesn't seem to me as if we're running out there.
Okay.
Any other comments before we end up? Do you have any other comments, Stig?
Not from me, no.
Great, good meeting.
Well, I can say that obviously, yeah, there's a lot to discuss on the mailing list, and also how the work should be done forward in the IETF, and there's this buff and so on. So, yeah, we'll see what happens next. But yeah, we should ideally have ongoing discussions on the mailing lists and not just wait for the next IETF for the next buff.
For sure. Get some rest, Stig. Feel better, and thanks everybody for attending PIM.
Yeah, thanks everyone.
See ya.
Yeah, all right, bye.
Thanks, Torles.
Thanks, Torles.